You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Specialized deployment models extend the foundational ideas covered in earlier episodes by introducing more complex arrangements of cloud services across providers or layers. These models, multi-cloud and cloud within a cloud, represent evolved architecture patterns that appear in larger enterprise and hybrid environments. Cloud Plus includes these models in scenario-based questions to assess a candidate's understanding of cloud distribution, nested abstraction, and cross-platform governance. Mastering these configurations requires clear differentiation from traditional deployment models. The multi-cloud model involves using services from two or more distinct cloud providers within a single enterprise or application environment. Each provider operates its infrastructure independently, and the organization consumes specific services or capabilities based on its own needs. Workloads may be split across providers for strategic or compliance reasons, or to match the performance profile of each platform. Multi-cloud designs are typically adopted to avoid dependence on a single vendor, increase resilience, or maximize technical advantages across ecosystems. In a multi-cloud environment, each platform may be assigned different roles. For example, one cloud provider may handle storage, while another hosts compute-intensive workloads. This segmentation allows organizations to optimize for cost, compliance, or geographic availability. Unlike hybrid models, which link cloud and on-premises systems in a unified workflow, multi-cloud models focus on distributing workloads between multiple cloud platforms without necessarily linking them operationally. Cloud Plus questions may include scenarios where these distinctions must be clearly recognized. Hybrid cloud and multi-cloud are often confused due to overlapping language about workload distribution. Hybrid cloud refers to integrating private and public environments, often with data or applications moving between them. Multi-cloud refers specifically to using multiple cloud providers simultaneously, regardless of whether a private component is involved. Cloud Plus expects candidates to separate these concepts and identify which model is in use based on clues about platform diversity, integration level, and provider relationship. The use of multiple cloud platforms increases management complexity. Each provider has its own interface, API structure, pricing model, and security configuration. Managing these environments requires unified monitoring tools, centralized identity management, and consistent policy enforcement. Automation becomes more important as organizations attempt to standardize operations across platforms. Cloud Plus may assess knowledge of the tools and methods used to maintain visibility and control in multi-cloud deployments. Resource portability across platforms becomes a concern in multi-cloud strategies. Ideally, workloads or data should be able to move between providers with minimal modification. In practice, differences in virtual machine formats, API calls, and service definitions make portability a challenge. Some applications must be refactored or reconfigured before migration. Cloud Plus exam questions may present scenarios involving workload relocation or failover that require identifying the portability constraints associated with certain services or platforms. Maintaining data consistency across multiple clouds introduces technical challenges. When the same dataset is accessed from different providers, latency and replication delay can cause stale reads, write conflicts, or system performance issues. Consistency models vary by provider and by storage tier. Cloud architects must select replication strategies that match the application's tolerance for inconsistency or delay. Cloud Plus includes these considerations when testing understanding of synchronization and workload design in multi-cloud environments. Security in multi-cloud environments is complicated by the diversity of tools, terminology, and policy structures used by each provider. Each platform may define roles, access control lists, and encryption practices differently. This requires administrators to build identity federation systems, centralized key management, and cross-platform compliance monitoring. Cloud Plus exam scenarios may test understanding of how to maintain consistent identity and access controls when different security models are used by each cloud vendor. Cloud within a cloud refers to a layered or nested model in which one cloud environment hosts another logical or virtualized cloud. This model introduces additional abstraction by encapsulating a subcloud within an overarching provider. One common implementation is a managed Kubernetes platform running inside a broader IaaS environment, effectively creating a cloud platform within another cloud service. Cloud Plus treats this model as an advanced variant that builds on concepts of isolation, control, and multi-tenancy. This nested model is often used in simulation, isolated testing, or infrastructure sandbox environments. It allows architects to build encapsulated service zones that behave like independent environments within a larger cloud. Use cases include replicating production-like settings for development, managing tenant-specific services, or creating virtualized environments for internal business units. These use cases appear in Cloud Plus as indicators of layered resource design, delegated control, or high-density multi-tenant service delivery. The risks associated with cloud within a cloud models are primarily due to added complexity and abstraction depth. Each layer introduces a new set of dependencies, configurations, and monitoring requirements. If a service outage occurs in the outer layer, nested services may be unreachable. Similarly, misconfigurations at the outer layer may block visibility or access to internal resources. The exam may ask about fault isolation, performance management, or monitoring tools in contexts where one cloud is embedded within another. The increased abstraction of nested cloud models requires deliberate architecture to preserve isolation while enabling communication between layers. Misaligned policies between the host and guest environments can cause errors in service visibility or access. Cloud Plus expects candidates to recognize when layering is useful and when it introduces unnecessary risk. Questions may describe role inheritance failures, nested network segmentation, or failed update propagation between host and subcloud environments. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Performance in nested environments can be affected by the compounded overhead introduced by multiple layers of abstraction. When one cloud provider hosts another set of virtualized services inside its infrastructure, additional processing is required to translate operations between the base layer and the nested layer. This layering can introduce latency, reduce throughput, and complicate performance tuning. In Cloud Plus scenarios, performance questions may test your ability to identify when nested complexity is affecting bandwidth or compute response times. Monitoring performance within a nested deployment requires tools that can observe both the outer environment and the encapsulated internal cloud. Metrics must be collected from different control planes, sometimes using separate agents or protocols. Cloud Plus exam items may reference misaligned alert thresholds caused by isolated monitoring systems. The candidate must recognize the need for centralized performance tracking that can correlate alerts across multiple abstraction layers to maintain visibility into system health. Identity and access control in cloud within a cloud models adds layers of delegation. The outer environment must either pass identity assertions inward or permit a replicated access model to be deployed within the nested layer. This creates the risk of orphaned roles, misaligned privileges, or broken inheritance if access definitions do not propagate correctly. Cloud Plus questions may describe failures in administrative access or tenant segmentation, and expect candidates to recognize that nested cloud layering is the underlying cause. Managing permissions in multi-tenant nested models requires more than traditional role-based access control. Some nested services require scope delegation, where an administrator has privileges only within their assigned environment. Others require synchronized identity services to ensure login credentials are valid across both layers. If synchronization is not properly timed, role propagation errors can prevent access or result in elevated privileges. Cloud Plus candidates should understand these challenges when analyzing nested access structures. Licensing and cost modeling in nested deployments introduces complexity due to overlapping subscription layers. The outer cloud provider may charge based on infrastructure usage, while the inner cloud services introduce their own licensing models, which may include user seats, feature tiers, or usage thresholds. In such designs, organizations may inadvertently duplicate licensing costs or lose visibility into sub-cloud resource consumption. Questions on the exam may involve analyzing a cost scenario and identifying the cause of unexpected billing growth. Accurate usage tracking requires tools that can monitor resource consumption across both layers of a nested cloud. While many cloud platforms offer dashboards or metering tools, these may not extend visibility into nested services without additional configuration. Organizations using layered models must deploy agents or APIs that report on both infrastructure and internal service usage. Cloud Plus exam questions may reference misaligned reports or over-budget alerts caused by gaps in monitoring between layers. Service integration across multiple clouds requires deliberate planning to ensure APIs, authentication protocols, and data formats align. In multi-cloud environments, services must often communicate through standardized protocols such as HTTPS, RESTful APIs, or message queues. Bridging services across providers may require load balancers, gateway endpoints, or service meshes. Exam scenarios may involve describing a failure to connect services hosted on separate clouds and asking which integration method resolves the issue. Authentication between services in different clouds may fail if credentials or access tokens are not trusted across provider boundaries. Identity federation allows a central authority to validate users or services, even if they are located on different platforms. Cloud Plus may include questions about failed integrations due to incompatible identity providers or missing token delegation. Candidates should recognize when cloud-native authentication methods must be supplemented with external federation tools to support multi-cloud operations. Compliance and governance considerations expand in multi-cloud and nested environments due to the need for policy enforcement across technical and organizational boundaries. In regulated industries, data jurisdiction must be tracked to ensure it does not cross into restricted regions. Audit logs must be synchronized and formatted in a way that supports cross-cloud reviews. Cloud Plus scenarios may test awareness of how governance frameworks apply when services span providers or when data is moved between abstracted environments. Nested environments introduce complications in assigning audit responsibility. If a service running in an inner cloud layer generates a security event, determining whether the responsibility lies with the platform host or the nested service manager becomes difficult. Candidates may be asked how to design audit trails that support attribution in environments with shared control layers. This may include using agent-based logging, event tagging, or separation of logging channels across boundaries. Monitoring across specialized models requires consolidated data pipelines that ingest metrics, logs, and status alerts from multiple systems. Centralized dashboards must normalize and visualize cross-cloud data in a unified way. Candidates may be asked to choose tools or configurations that detect performance anomalies in distributed systems with delayed or siloed data. Questions may also highlight the importance of correlating alerts across service layers to isolate failure sources in multi-cloud or nested environments. Alert configuration in layered cloud models must account for dependencies that exist between systems. A service hosted in a nested environment may generate false alarms if latency spikes occur in the underlying provider. Thresholds must be adjusted to reflect realistic performance expectations across layers. The Cloud Plus exam may present alerting behaviors that result in noise or missed issues and ask how the alerting system should be refined to support service reliability in complex environments. Choosing between multi-cloud and cloud within a cloud architectures depends on an organization's priorities related to autonomy, integration, and resource control. A multi-cloud model provides geographic and platform flexibility, allowing for parallel operations with reduced vendor risk. A nested model emphasizes layered separation and modular service deployment within controlled boundaries. Cloud Plus candidates should be able to match organizational goals to the most suitable deployment pattern, especially when scenarios describe performance, security, or compliance needs. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.